All right. Okay, you guys, we're going to talk about this question really quickly. You should know the answer to this without even graphing it. So is it the first one or second one? Okay, why is it the second one? It's the exponential. If you remember right, last time I told you guys to try and figure out how you could make a kind of a polynomial equation or quadratic grow faster than an exponential. And remember, some of you guys kept on thinking you had it, but if I went up high enough, what always happened? The exponential always would intersect with it and go steeper, wouldn't it? Okay. I have to tell you, 0.3 times 2 to the x power is going to go slow at first, but after a while it's going to start growing fast, whereas this one right here is going to be growing fast from the start, but it's not going to get as high as fast as the bottom one. Okay. You could graph it and find out, but anytime you have an exponential equation, it's always going to go faster than a quadratic or a cubic or a fourth power or a fifth power polynomial. Eventually, the exponential is going to pass it up, right? Now, if you were doing it on an interval like 5 to 10 or 10 to 15, then you might want to check these because this one might be growing faster at first than the exponential. Okay, so you have to check them at first. All right, so we've got that. Okay, I want to go to your inverse worksheet. Get that one out. Okay, before I do that, okay, now you guys, some of you are having trouble. I think you guys understand the concept of an inverse, don't you? How do you find an inverse?
Switch X and Y.
You switch x and y. So if I'm giving you a problem like this, f of x equals 3x plus 12, okay, if I give you one like that, basically, to find the inverse, I gave you 4 steps. First of all, let's make the f of x a y, right? So it makes it easier to work with. An inverse is found by just switching the domain and range. Well, what represents the domain? What represents the range? X and y. So we change, or we switch the x and the y, right? And then we solve for y. Step 3 would be to solve for y. So I would minus 2 and divide by 3. Oh, it is 12. Sorry. So minus 12 and divide by 3 is going to be 3 into 12 is 4, right? And there I have y equals 1/3 x minus 4. And the last step was to change to change y to f inverse of x. So it's 1/3 x 4. That is what you do to find an inverse, right? Okay, how many of you understand that? Okay, Carly? All right, good. All right, I just didn't see. Hey, so that's how you find it. Now, the problems I gave you on the assignment, all of a sudden I've given you cubic functions and rational, okay, and things like that, and all of a sudden now solving for it is what you're having problems with, right? Okay, so which one of those would you like me to go over? Okay, let's go over number 5 first. What is number 5?
F of X equals 4.
That's it? Okay, you guys, this function right here is a rational function. How can we tell? How do we know it's rational? Equation recognition here. Why? Because where's the x? It's on the bottom, right? It's in the denominator. So that's why it's rational, okay? Now by squaring it, you guys, 1 over x looks like this. It has this part right here and this part right here. Whenever you square the bottom, when you square it, it's going to make it a little steeper. It's going to make it a little steeper like this. It's going to be closer to the 0, 0. But the bottom part's going to flip up like this. So this is what it's going to look like, okay? Got that? By the way, does this pass the horizontal line test? No, because a horizontal line would go through it right there and there. So it doesn't pass the horizontal line test. Where could I cut it at so that it passes the horizontal line test? At the origin. I could cut it right down the middle right here and only take the right side, right? Okay, and so that's what we're going to do. We're going to say we're going to only take x is greater than or equal to 0 on this one. Okay, so I'm telling you that so when we solve this, remember when you take the square root of both sides, you do plus and minus usually? We're only going to do the plus sign, okay? So we're going to go over here. We're going to go through the 4 steps of solving it. First of all, and we're going to kind of skip this step. We're going to just assume that f of x is a y right here, and we're going to switch x and y, right? So I'm going to have x equals 4 over y minus 3 squared. Does everybody understand that that's how you find an inverse? Switch the x and y. That's switching the domain and the range. So whenever you see someone say, find the inverse, all it means is to switch the domain and range. Switch the x and y coordinates. Or switch the x and y variable if you're working with an equation like this one. Okay, then I have to solve it for y. This is where you guys got in trouble, right? This is where it made it harder. Some of you guys came and asked me questions, and you got it now. But what do you do? Those of you who asked me questions, what do you do to both sides? Okay, you times both sides. Y minus 3. Why do you do that? Yeah, you have to get the y out of the denominator because you want to solve for it, so you got to get it out of the denominator. Well, when I do this, what happens on the right side of this equation? Yeah, the y minus 3 squareds cancel out, right? Okay, so now I have y minus 3 squared times x equals 4. Okay, now I got to get y by itself. Divide by x. Why divide by x? Well, if I divide by x, these x's cancel out right here, right? And I've gotten a little bit closer to getting y by itself. So I've got y minus 3 squared equals 4 over x. Okay? Any questions so far? Okay, now y is being minus 3 is being minus from it, but more importantly, it's being squared, right? Which one do I have to take care of first? The square. How do I do that? Use square root. That's how you undo it. You take a square root of both sides. Okay? And I am going to get the square root and the square undo each other. I'm going to get y minus 3 equals plus or minus the square root of 4 over x, right? But do I need the plus and the minus both? We just need the plus. Why do we only need the plus? Yeah, I only remember, over here I restricted the domain. I only wanted the right side of that. Okay, and so that's why, is we only took the right side of that. Okay, so I only want the positive of the square root of 4 over x. Well, I've almost got y by itself. What's the last thing I got to do? Plus 3. So I have y equals 3 plus the square root of 4 over x. Okay. That's not efficient? What do you mean? You know a faster way to do this? Okay, I was just checking. Okay. And we have one more step. We forgot one thing. What is it? Change the y to f inverse of x. So you have function notation, right? Any questions there? Okay, no questions? That is ugly, Austin. Okay. Huh? Oh, I recorded that? No. Basketball? Girlfriend? Did someone not yell 4 or what? What? You were swinging, the ball bounced up and hit you? That's kind of an embarrassing story, isn't it?
No, the real story is he's wrestling with fear.
Okay. Okay. That, no. Actually, that looks cool. I wish I had one of those right now. So, okay. All right. All right. I thought for sure it happened during basketball, so. Yeah. Yeah. Can you even see out that eye? Okay. Yeah, that's tough. Okay. All right, next problem. What are we going to do? Number what? I'm going to do 8, and then I'll come back and give you a hint on 4. How's that? 8. Okay. 8. Can I borrow this? 8 is the story problem. Airplanes are often used to drop water on forest fires in an effort to stop the spread of the fire. The time t it takes the water to travel from height h to the ground can be derived from the equation h equals 1 half g times t squared. Let's write that down. H equals 1 half g times t squared, where g is the acceleration due to gravity. By the way, acceleration due to gravity, you guys will see this a lot in your math careers. Okay? It's the same number every time. If you're measuring in feet, it's 32 feet per second squared. If you're measuring in meters, does anybody know what it is? 9.8. Who said that? Andrea, have you seen it before? 9.8 meters per second meter squared. Okay? Meters per second squared. Meters per second per second. And that's the acceleration due to gravity. That's how fast it's accelerating, not the speed. That's how fast it's picking up speed. So that's numbers you guys will see all the time. Okay, so we know what give time as a function of height. So this time, what they want to do, they want us to find the inverse. They want us to solve for what? T. Except for we're not going to switch the h and t this time. All we're going to do is solve for t. So how do I solve this equation for t? What am I going to do first? Times by 2. If I times both sides by 2, this 2 will cancel that one over there, right? And so I have 2h equals g times t squared. What am I going to do next? Divide by g. G is being times by t squared. The inverse operation is to divide by g. So we divide by g. Those cancel out, and I have t squared equals 2h over g. Then I square root both sides. And I get t equals plus or minus 2h over g, right? Oh, I did. Thank you. I forgot the square root sign. Anybody listening at home? Okay. All right. So, okay, so now we have a function in terms of t, okay, that is given the time t as a function of height. So now, part B, the reason we did this is so we can answer part B a little bit easier. Suppose a plane drops water from a height of 1,024. So using this function, we know the height is 1,024. How many seconds will it take for the water to hit the ground? Do you see why we solved for t, you guys? We solved for t. I mean, if I could have left it this way and put 1,024 in for h over here and then evaluated it. But now it's all done for me right over here. We're going to come up here. We're going to go t root of 1,024, because that's what h is, divided by g. We know what g is. What is it? 32. Okay? Now, I'm going to get a positive answer and a negative answer. The nice thing about this is I'm going to be able to tell which answer I want. Why? How? Because you can't have negative what? time. We're not going to have negative time here, are we? Okay? Because we're talking, you could have negative time if you're talking about the past, but are we talking about the past in this problem? No, we're talking about how long is it going to take in the future. So we only really want the positive of this. So someone go 2 times 1024 and divide it by 32 and tell me what it is. 64. And then I have to take the square root of that, which is, if I would have kept the negative, my other answer would have been -8. But we know it's not that. So it took 8 seconds. Got it? Thanks, Kai. All right. Any questions right there? Do a problem like that. Okay. I'm going to give a hint on which number? 4? Okay. Number 4. Can I see this? F of x equals the cube root of x minus 1. It said x minus 1, right? Okay, you guys, I'm going to switch x and y, right? There's my inverse, but I got to solve it for y. How am I going to get rid of the cube root, Andrea? Not to the 1/3 power. To the 3rd power, yeah? Because this already says y minus 1 to the 1/3 power. Okay, because if I wrote it as rational exponent that we learned at the first of the year, remember that? Okay, so if I raised both sides to the 3rd power, then I have x cubed equals, and these cancel out, just y minus 1. Add 1 to both sides. I says I was only going to give you a hint, didn't I? There it is, just write the inverse, F inverse, right? Okay, all right. Do you guys need a little hint on number 1, some of you? Okay, let me help you out with number 1, and then you guys can do the rest on your own right there. But do you understand what's going on with this one right here? Okay, number 1, you have a graph, and I'm going to bring up one of my graphs right here. And what we need to do is we need to make an xy. Now, what is the equation for this one, you guys? What? X minus 1 quantity cubed plus 1? Is that what it is? Okay. Now, you guys, if you notice your graph doesn't have very many, it doesn't stretch very far, it doesn't stretch up and down very far, right? So we want to keep all our numbers close to the origin. So what x numbers might I choose? -2, -1, 0, 1, 2, 3, those numbers? Okay, let's try some of those numbers and see what we get. If I put -2 in there, -2 subtract 1 is a -3. -3 cubed is -27. Add 1 and you get -26. That's way off my chart. So I'm probably not going to worry about graphing that one. Okay, let's put -1 in there. What's -1 minus 1? What's -2? What's -2 cubed? -8. -2 times -2 times -2 is -8. Plus 1 is -7. So everybody graph -1, -7. -1, -7 right there. Okay. Now I can put 0 in. 0 minus 1 is not 0. -1 cubed is -1 plus 1 is what? 0. So we can graph 0, 0. Okay, 1 minus 1 is 0. Cubed is 0. Plus 1 is 1. Everybody graph 1, 1. 2 2 minus 1 is 1. 1 cubed is 1. Plus 1 is 2. So 2 comma 2 is on my graph. 3 minus 1 is 3 minus 1 is cubed is 8 plus 1 is 9. So I'm going to go to 3 comma 9. That's pretty much it, isn't it? What kind of function is this? Cubic. So my next one would be way off the chart, wouldn't it? So this function goes something like this, you guys. Now, it asks me to graph the inverse. How am I going to find the inverse? Good. So we're going to make a table. We're going to call the green table the inverse, right? And all I have to do is switch all these numbers. Negative 26, negative 2. Negative 7, negative 1. 0, 0, 1, 1, 2, 2, and 9, 3. Okay? We got 3 points that are the same, right? Okay? But we have the other ones that are not the same. So negative 2, negative 26, we're not going to graph. Negative 1. No, negative 7. Negative 1 would be right here. 0, 0, right here. 1, 1, right here. 2, 2, right here. And 9, comma 3, right here. This graph's going to look something like this. There is my inverse. That's all you do on 1 and 2. You graph the inverse. Alex, how do you find an inverse? There you go. Everybody got that? Okay. All right, you guys. We've done all but 2 problems on this, right? You should know how to do that. If you've got it done, go put it on the flapper board. If not, finish it up and then go put it on the flapper board, okay? Okay, now if you take out your quiz, I'm going to answer questions on the quiz. Okay, Haley. Number 2. Okay. You guys, I did not use this word when I was teaching you this, and I don't know if this is what confused some of you guys. But do you guys know what the word transform means? Change. I use the word change, okay? So hopefully if you knew the word transform, you could get that. But it says transform f of x equals x to identify the vertex. Okay, I am looking for a vertex. Well, are vertex zeros? No, we're doing number 2. Sorry. Someone asked me about number 2. This is number 2. Okay? It asked me to find the vertex. Well, what do I do? Say that again. Just put it into the vertex form. That's it, right? So y equals x squared plus 6x plus 13. And I've got to change that to vertex form. Raise your hand if you remember how to put that in the vertex form. Raise your hand if you forgot. Okay. All right. So, now, hey, you guys, I would write this somewhere in your notes because you're going to want to study this between now and the test, right? You never took? Oh, you weren't here? Oh, did you? Okay. This is a review, but it is very basic. It's probably not enough. We're going to go over some more problems here in just a little bit. But we got to hurry on these. So, you guys remember, we have to complete the square. Remember, to complete the square, I group the first two terms like that, and I leave a space to complete the square. What number do I put in that space? Where do you get that from? Half of 6 is 3, right? And then what do? I square it. What's 3 squared? 9. Okay, remember doing that now? You guys have forgot? Okay, now, I can't just add 9 to one side of an equation without compensating for it somehow by either adding 9 to the other side or subtracting 9 from the same side I added 9 to, right? In a different form, right? So, what do I add the 9? Okay, now, I have enough information. I have this perfect square trinomial. I can factor it. What two numbers can I times together and get 9, and add together and get 6? 3 times 3 is 9, 3 plus 3 is 6, right? It's always going to be a perfect square. In fact, the number is always going to be whatever this number was, whatever half of 6 was, okay? So in this case, I have y plus 3 times, or not y plus 3, x plus 3 times x plus 3. What's 13 minus 9, you guys? 4. What's the short way of writing x plus 3 times x plus 3? All right, x plus 3 quantity squared. What? Good. The vertex, actually it's negative 3 comma 4. The vertex is at negative 3 comma 4, you guys. Vertex. Got it? That's all you do. Can you guys handle that? Okay. All right, give me another question. Which number? Number 5. What was number 5 saying? Oh, you have a 1 by 1. Remember we did this in groups, you guys? We actually did this exact problem. And I could go 4 by 4 and so forth, right? I asked you to come up with an equation that would model this pattern. The answer is x squared. So if I was going to write an equation, it would be y equals x squared, right? Don't forget the y. Or f of x will work. Y equals x squared. Whatever the length, and what does x represent here, you guys? The length of the side. This is a 1 by 1, 2 by 2, 3 by 3. It represents the length of a side, right? Okay, and that would give you the area, or how many cubes were used to do that, right? Okay, another question. Audrey, 9. What does 9 ask? What kind of a graph is x minus 4 squared plus 1 going to give me? Quadratic. It's going to give me, what's the graph, though? You're going to name the type of equation. Parabola, right? What's the problem with the parabola, you guys? Doesn't pass the horizontal line test. What? Angle like that? Okay, you guys, where's the vertex of this parabola? 4 comma 1. Does it open up or down? How can we tell it opens up? Yeah, there's no negative in front of the function, right? Okay, that's what that graph looks like. Well, if I was to get it, instead of the vertex, so who said that? Andrea said 1 comma 4. Why at 1 comma 4? X and Y, right? It's the inverse. 1 comma 4. I need to move that X down a little bit, or that. Okay, 1 comma 4, right? And guess what? Which way is it going to open up? Sideways, right? Okay, what's the problem with its inverse? It's not a function. Why not? It doesn't pass the vertical line test. This green one doesn't pass the vertical line test. The vertical line will pass through more than once. Okay, now, we could have told by doing the horizontal line test on the parabola, right? Parabola didn't pass the horizontal line test. Its inverse isn't going to pass the vertical line test. Got it? So, on this one right here, we need to restrict the domain. Well, where are we going to restrict the domain of this red one right here so that it passes the horizontal line test? Kayla, how did you get that number? It's the vertex. That's how easy this is, you guys. It's the x-coordinate of the vertex. I'm going to cut this. We're going to cut this in half. We cut the red one in half. And we're going to only take the right side of it. So guess what? I'm going to erase the left side of this. Okay? So we're only going to take the right side of this. And we go up like that, right? Okay. Yeah, always do the right side. Okay, so when I graph it, it's only going to graph the top side of the inverse, okay? And then that inverse will be 1 to 1. Okay, so the answer was, whatever the x-coordinate of the vertex is, that's what you're going to restrict, and greater than 0. You can take the right side of it, so make it greater than 0, and you have it. Notice, are these reflections over the line y equals x, you guys? Those look like that they are symmetric over that line. Yeah, and that you can tell it's an inverse when it's symmetric over that line. So do you guys understand how to restrict it? Anna, you always take the x-coordinate of the vertex. What if it was an absolute value equation? Doesn't an absolute value equation have a vertex? Same thing, right? You can do. All right. Those would probably be the only two I'd put on there. Okay? All right. What other questions? What does 7 say? So that what was the function f of x equals what? Oh. Of what? Of x? 6 units left and what? 3 units up. Okay. What did I mean by ABS, you guys? Absolute value. That's how the calculator puts it in, so that's why I wrote it like that. Well, because I didn't have symbols on this thing to put it that way when I wrote it. So, absolute value of x. Now, we know how to shift things left and right, don't we? If I want to shift this 6 units to the right, what do I do? Okay, I don't want you to say I want you to say replace. Everybody, horizontal shifts. Everybody write this down. Replace. It's replace. Replace with what? Again, Kayla. I'm going to use the absolute value signs instead of ABS this time, you guys. X minus 6 will move it. Remember, it moves it in the opposite direction of the sign. Oh, I wrote an arrow to the right, and I was thinking left. Thank you, Haley. So what does that change, you guys? Plus 6, right? Because I'm moving it left, it's got to go the opposite direction. Plus 6. And how do I move a function up, you guys? Add 3 on the outside. That's when you add 3. You guys, horizontal shifts, you replace. Vertical shifts you add or subtract, okay? Got that? You insert horizontal shifts, okay? They're on the inside of the function. Yeah, it's going to go the opposite direction of the sign. Okay. Is that all the questions you had on this little quiz thing? That's the answer. That would, okay, because look, you guys, let's look at the graph. What does a absolute value equation look like? A regular one? An absolute value of x looks like that v right there, right? Where's its vertex? 0, 0, 0. Okay, now, if all of a sudden I move it to the left 6 and up 3, now all of a sudden I've got 1, 2, 3, 4, 5, 6, up 1, 2, 3. So my new equation, left 6, up 3, is going to go like this, right? There's my new equation right there. I moved it left 6 and up 3. Okay, that's the transformation that took place. All right. What else do we have? We understand that? Okay, now, I want you to use this to study for the test, and we'll turn it in next time. Okay, so keep it until next time, and we'll use it to study for the test. Now, I want everybody to get a whiteboard and marker. Whiteboard and marker. We're going to do a little bit more reviewing. Okay, here we go. You guys, we're going to do numbered heads. This is how it's going to work. You four are a group. You four are a group. You three back there are a group since we're missing Kobe. You four are a group. You four are a group. You four are a group, and you three are a group. Okay? Got it? Okay, here we go. Okay, I want you to find F plus G. And then remember, I will spin the spinner to see which person in the group gets it. But I want you guys to all do these together. I've got my person. You guys all know what numbers you are in your group? This is how I start it. This is 1, 2, 3, 4. So 1, 2, 3, 4. You guys got it? 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Let's go over here. Kayla, 1, 2, 3. That way, okay? 1, 2, 3, 4. Got it? All right. F plus G. Everybody, share your answers with each other. See if y'all got the same thing. Okay, I already spun. Person number one, show me what you have. Correct, 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 correct. Okay, all we had to do is x minus 6 plus 3x plus 4. And if you combine like terms, x plus 3x is 4x. Negative 6 plus 4 is a negative 2, and there's your answer. Any questions there? Okay. Second one, I want you to find f minus g. F minus g. Okay, so on this one right here, you guys, f times g, we have x minus 6 times 3x plus 4. And we got to distribute. X times 3x is 3x squared. X times 4 is 4x. Negative 6 times 3x is negative 18x. Negative 6 times 4 is negative 24. Add the two middle terms, and we get negative 14x. Is that what you had, Carly? I'm sorry. Oh, okay. I couldn't read it. Okay, so that's what you have. All right. Now, I need you to find f composed of g of x. F composed of g of x. I'll go back up to show you which one's f and g. F was x minus 6, and g is 3x plus 4. So you're finding f composed of g of x. You're finding f composed of g of x. Good, you guys all got it right? I'm putting g into f, right? So f was x minus 6, and so I'm going to put g in for that x that was there, which is 3x plus 4. I replace the x in the f function with the g function, which is 3x plus 4, and I add like terms, and I get 3x minus 2. Any questions? Could you do it the other way too, you guys? Do I need to go over one? Because we're kind of rushed. Does anybody need practice? Okay. I want to do one more, though. You guys, here we go. I'm going to move this back up. H of x is equal to x. Now I want you to do this. Right up here, I want you to find f composed of g of h of x. F composed of g composed of h of x. I should have switched it up a bit, huh? I made it too easy. There's a problem like this on the test. Okay, you guys? So you need to know how to put them all in the function. So what is it? It's the same thing, isn't it? Because if you think about this, you already did f composed of g. So, and you already have x. So you're going to put x in for g. You're going to put function h, which is x, in for g, which is going to be the same thing, 3x plus 4. And then you're going to put that 3x plus 4 in for the x right there, which is going to give you the same things we just did. Okay? I should have changed it to something like 2x. That's how simple it is on the test, though, so you know. Okay? All right. Hey, you guys, let me just review something with you. You guys, do you remember what the other way to write do you remember how to write that? in rational exponents. Okay, you guys all remember that? X plus 4 to the 2/3 power. One of the problems on your test is going to ask you, it's going to ask you for the inverse, and after you get all done, it doesn't write the answer like this. It writes the answer like this. So don't forget rational exponents. Do you understand that? Okay, rational exponents. Okay. You guys know how to find inverses? I'm not going to go over inverses. We just went over them. Switch x and y and solve for y, right? Everybody got that down? Okay. You guys, you're going to have to write a model of an exponential function. You guys all know what an exponential function looks like. What does it look like? It has, where's the variable? Okay, now, it's going to give you a real life problem. Okay, and it's going to ask you to write one. No, you're going to have to come up with an equation. It's going to be, the equation is going to be of this form right here. Y equals A times B to the x power. You're going to have a coefficient of A, and then you're going to have the base B, and then raised to the x power. So anyway, that's what it's going to look like. Just want to remind you of that. You guys, I have a problem like this. 0 equals 3x squared minus 6x. And I want you to find the solutions of that for me. Could you do that? Remember, first of all, what kind of equation is this? It's quadratic. How can you tell? It's squared, right? Okay, it's squared. And so whenever we set a quadratic equation equal to 0, it means find the zeros. So I could have written this as y equals 3x squared minus 6x, and I could have said find the zeros, and you would have replaced y with 0 to find the zeros, okay? The zeros are what? The x-intercepts. What did we learn? What method did we learn for finding x-intercepts? What form did we have to put it in? Factored form. Now, that's right, except for this equation is a little bit different. What's different about this equation? The constant is 0, right? Okay, so this one factors a little bit different. It's actually easier. It's just that I want to make you aware of it. Okay, you have to find common factor. What is the greatest common factor? 3 is part of the greatest common factor, but it's not the greatest common factor. 3x. Okay, so I am going to factor out a 3x, because there's at least a factor of 3 and x in each term. If I take out a 3x of the first term, what am I left with? X. Because think, you guys, is 3x times x 3x squared? That's how you know if you factored it right, is if you can times them back together and get that number. Okay? If I take a 3x out of a negative 6x, what am I going to be left with? Is 3x times a negative 2 a negative 6x? Yeah? So I've factored it. Now, how's that going to help me find the zeros? Instead of having two binomials, what do I have? A monomial times a binomial, right? All I have to do is set each factor equal to 0. 3x equal to 0, x minus 2 equal to 0, and I got my answers. What's this one going to be? 3 times what number is 0, you guys? 0. 2 minus what? 2 minus 2 is 0, right? So this one is 2, and there's my two zeros right there. Yeah. I'll wait right there for a second. Yeah. Hey, you guys, these are quadratic equations. You're just factoring a little bit different because it's missing the constant term. You just got to factor out the greatest common factor. If you have a quadratic equation that's missing the constant term, you're going to always be able to factor out an x, at least. And then you got to see if the first two numbers have a common number that can be factored out. And if they can, you can come up with this. X equals 0 and x equals 2. Okay, got it? All right. Can you guys factor something, put it in factored form? Does everybody know how to do that? Yeah. It's going to be something simple like this. It's going to say write this in factored form. Could you write that in factored form? Yeah. Wait, let me see again. Yep. What two numbers can you times together and get 18 and add together? You know what? I did this wrong. Hold on. How about if I made them negative 18? Then could you do it? Sorry. If I made negative 18, could you do it, you guys? What does it factor to be? X minus 9 and x plus 2. Because 2 times negative 9 is negative 18, and negative 9 plus 2 is negative 7. Got it? Well, there's none on the test. I'm not going to worry about it right now. Okay? All right. Hey, you guys. I want you to think about this. This is going to be on the test. Y equals a to the x. It's going to ask you what point does any quadratic equation of this form have in common? I'll give you a hint. Graph a bunch of them. Which point will all of these cross through? That's what it's asking. Don't say it out loud. I want you guys to all investigate yourself. It will be on the test. Okay? Do you guys know what the difference is between exponential growth and exponential decay? What changes? What is this? Decay. Remember, if A is between 0, if A is between 0 and 1, then it's exponential decay, okay? In other words, if this number right here is exponential growth decay. Remember, though, I could have written this as 2 to the negative x power. Do you remember that? Because that just, a negative exponent is just going to say take the reciprocal of that number right there. If A is greater than 1, then it's what? Growth. Do you remember that? Do you guys remember how to find average rate of change? What is average rate of change, everybody? Slope. So if I give you an equation, y equals x squared plus 4, and another equation, and could you find, if I said find the interval, find the average rate of change on the interval 2 to 4, would you know what I meant? Find the slope on the interval 2 to 4. If you don't know, talk to someone. Now, It's also going to give you one where I'm give you two functions, and you have to see which one has a greater average rate of change over a interval like 2, 4. Can you do that? Okay. Hey, you guys. Hey, everybody. Remember the function I gave you that looked like this? And you had to come up with an equation? It was a composition of functions. Remember that? It was the absolute value of x squared minus 4. Do you guys remember that? There's going to be one similar like that on the test, except for it's not going to be, I don't think it's a quadratic. Okay? So see if you can figure it out. Hey, you guys, I won't be here next time when you take the test. I'm going to have a short little review at the first of class, and then she's going to take you down there.